Welcome back, everybody. Mr. Longo here to talk to you about solving systems of nonlinear equations. Okay, so before we begin, let's wrap our minds around what's happening here. Nonlinear systems means we can have more than one solution. Because if it's a linear system, you're going to have two lines and they're going to intersect at one spot. Now that we are working with nonlinear, let's think about some of the possibilities. We could have a parabola and a line. They can intersect at two different places. You can have two different parabolas. You can have them intersect at one place, no places, or again, maybe two different places. And we can even get crazy and we can do a circle with a parabola and have four different intersections. Or we can do a circle and a parabola with three different intersections. There's all sorts of different combinations. But remember, the solution to a system of equations of some kind is where two graphs intersect. Okay? So the purpose of this video is to show you how to do it algebraically. Now, the first method I'm going to show you is using the substitution method. So right here we see that we have y is equal to x squared plus 3x minus 1. And what we can do is we can just take y and substitute it in here. Or what we can do is we could take the x, substitute it, or move the y over here, and have x is equal to y minus 7, and substitute that in there. I just want to show you one thing just so we can wrap our minds around what's about to happen. If you were to get y by itself for this one, then both of them are in graphing form. So y would be equal to x plus 7. Now the only reason why I wanted to show you that is because we know this is a quadratic and we know this is linear. There's no squared variables. So we could have a line that looks like that and have two different intersection points. We can have a line that just nicks it once, or we can have a line that never even touches it. So we can have two solutions, one solution, or we can have no solutions. So I just wanted to show you what type of situation we have coming our way. Okay? But again, the point of this video is to show you how to do it algebraically, so we're going to do it algebraically. Since I already got y all by itself over here, we're just going to substitute x plus 7 into this y. So we're going to have x plus 7 is equal to x squared plus 3x minus 1. And now we are down to one variable. Our y has disappeared because we decided to take the x plus 7 and substitute it into our y value. And now we're just going to solve. So 0 is going to be equal to x squared plus 2x minus 8 after you subtract the x and the 7 over to the right side. And now to factor, what multiplies to a negative 8 but adds the 2? That's going to be an x plus 4 and an x minus 2. So x is equal to a negative 4 and a positive 2. Now what that does is means we have to go back and substitute x in twice. So it's always easier to work with the smaller equations, so we're just going to say y is equal to the x plus 7, since we've already manipulated it. And we're going to substitute negative 4 in, and we're going to substitute 2 in. So one of them is y is equal to a negative 4 plus 7. So 1, y is equal to 3. Now it's important to remember what you substituted in there because of how we're going to write our answer. So we have x is negative 4 and it gave us 3. So one of our intersection points is negative 4 comma 3. You have to remember where each answer comes from because you must write it the correct way. And then, of course, we have to go back and use our 2. So we're going to say y is equal to 2 plus 7, which means we know y is equal to 9. So our other solution is going to be 2 comma 9. Okay, and that's how we use substitution to solve. So it's just like solving a linear system, but you might have to factor now. So you might have two different solutions to substitute back in to find your answer. So this was an example of a parabola and a line that intersected in two different places. So you can take your graphing calculator and type this into y1, that into y2, and you can use your intersection feature to find those intersection points, and it's going to give you the same answer. So that's how you can use your graphing calculator to check. Okay, elimination. Now, elimination is sometimes tricky. Now, just like elimination with a regular system of linear equations, you need to make a variable disappear by having opposite coefficients. So right here, you think you're already set up for it, but x squared minus x squared does disappear. You still have an x, because we would still have 4 x's. In order to use elimination with a non-linear system, the entire variable must disappear. So the first thing you're going to want to do for this is multiply the bottom one by a -1. That'll change it to a positive x squared minus 8x minus y is equal to a -22. Okay, and then what happens is our y's will eliminate and we will have just x's left. So we have x squared and x squared. That's going to give us 2x squared. -4x and a -8x is a -12x. Our y's cancel, and we're going to be equal to 6 minus 22, which is going to leave us with a -16. Okay, so now from there, we're just going to add the 16 back over to the left, giving us 2x squared minus 12x plus 16 equals 0. Factor out your GCF of 2, leaving you with x squared minus 6x plus 8. We can factor that to x minus 2 and x minus 4 because that multiplies to a positive 8 but adds to a -6. So x is equal to 2 and 4. So we found both of our x values again. So now we have to go back and find the y value. In this case, it really doesn't matter which equation you choose to substitute this back into, because they both have x squareds involved. So it doesn't matter. I'm just going to go back to the top one, and what we're going to do is just substitute in the 2 first. So that's going to give me 2 squared minus 4 times 2 plus y is equal to 6. So we obviously have 2 squared is 4 minus 8, so that's a -4, plus y, add 4 to both sides, and you're going to get y is equal to 10. So when we substitute in a 2, we get 2 comma 10. That's one of our intersections. We have to do it again. This time we're going to do it with a 4, so we're going to substitute in 4 squared, which is 16, minus 4 times 4, which is another 16, plus y is equal to 6. So y is just equal to 6, because 16 minus 16 goes away, so we have 4 comma 6. Okay, so again, all you have to do is take your graphing calculator and you can type that in, but if you look at what happened there, this was 2 parabolas that intersected in 2 different places. Okay? So that's that. Now you know how to use substitution and elimination. But what I did so far is just give you 2 easy ones. Here's a challenge question, and this is something that we haven't spent a lot of time talking about graphically, but whenever you have x squared and y squared and they're both positive and they have the same leading coefficient, that's actually a circle. And when you have one of them that's negative, you have what's known as a hyperbola. So these can intersect like up to 4 times as well. Again, the purpose of this video is not to talk about which one you're graphing, what shape, how to use your calculator. It's can you do the math algebraically? So I would like you to actually pause this video and see if you can handle a challenge question on your own. And if you can, you're ready to rock. So the best way to do this one, in my opinion, would have been to use elimination, because we have x squareds and y squared. So even if we were to get a variable by itself, we're going to have to take square roots. So in this case, elimination is better. We can easily eliminate our y squareds and have only x's left. So that's going to give us x squared plus y squared minus 16x is equal to a negative 39. And I'm going to rearrange the bottom equation. We need to get an opposite, so we're going to multiply everything by a negative 1. So that is going to give us x squared minus y squared minus 9 equals 0, but we need to bring the 9 over to the right as well. So now we have x squared minus y squared is equal to 9. And our y's will cancel. So now we're going to have 2x squared minus 16x is equal to a negative 30. So 2x squared minus 16x plus 30 equals 0. Factor out your 2. X squared minus 8x plus 15 is equal to 0. What multiplies to a positive 15 but adds to a negative 8? That would be a negative 5 and a negative 3. So x is equal to 5 and 3. So what's going to happen now? So we have to go back to one of our original equations. This one's easier to work with. So we're just going to use the x squared minus y squared is equal to 9. That's going to be a little bit easier to work with. But since we're solving for y, we're going to have to still do a little bit of work. So it's fine. It's not really going to change anything. So now we're going to take the x and we're going to substitute in the 5 first. So that's going to give us 25, because 5 squared is 25, minus y squared is equal to 9. Subtract 25 from both sides and we have negative y squared is equal to a negative 16. Get rid of the negative, so you divide both sides by a negative 1 and you have y squared is equal to a positive 16. Once you square root both sides, y is equal to plus or minus 4. Remember, whenever you're solving for a variable using square roots, it's plus or minus 4. So what just happened is 5 gave us an intersection point of 5, 4 and 5, negative 4. You have to remember to substitute in and write down both answers. And then when you do it again, we have x squared minus y squared, but this time we're going to substitute in a 3. So when we substitute in 3, we're going to have 9 minus y squared is equal to 9. Subtract 9 from both sides and you have negative y squared is equal to 0. And of course, once you divide by 0 or the negative, you have y squared is equal to 0. So y is still equal to 0 because the square root of 0 is 0. So 3 gives us 0. So we actually had 3 intersection points. But again, if you know how to factor and if you know how to use substitution or elimination for solving systems, it's the exact same thing. We just have more challenging algebra to work with. All right, that's it for this video. This is Longo and I'm out. See you, bye.